when we look at biconditional statements, we have to recognize where they come from. So first of all, a biconditional statement is just a conjunction of a conditional statement and its converse. So remember before, a conditional statement is just an if-then statement, and its converse means that we take the conclusion and hypothesis and reverse the order. Okay, so symbolically, this would be the conditional statement. So P implies Q, and we're going to AND it with the converse of it, which says Q implies P, and what we end up with is that P implies Q and Q implies P. So we just put the double arrow there. It's also read as P if and only if Q. One other thing that you'll want to note is that instead of writing if and only if, sometimes we will write it as IFF. Okay. Additionally, we want to see that a biconditional statement is only true if both the conditional and converse are true, because of this statement here that it has to be true going this way as well as going that way. So both situations have to be true in order for the biconditional statement to be true. So let's work on number 1, and we'll get a little bit of exposure to that and maybe make this a little clearer. Okay, two angles are supplementary if and only if the sum of their measures is 180 degrees. So we want to first take the information and run it in this direction, and then we'll take the information and run it in that direction. What I mean by that is we're going to create the conditional going from left to right, and then we'll make its converse going from right to left. So here we see that if we go from left to right, if two angles are supplementary, then the sum of their measures is 180 degrees. So we just basically picked those phrases up, putting it in an if-then statement, because we can't have the if and only if. That tells us that it goes in both directions. So right now we're breaking it up into two separate statements, one in one direction, and then the other, the blue one, goes from right to left. So therefore, if the sum of the measures of two angles is 180 degrees, then they are supplementary. And so we just took this statement, the sum of their measures is 180 degrees, and made it the hypothesis, because that's what we do with the converse, and then use the beginning as the conclusion. Okay, so now that we have those, we have to decide the truth value. So we just look at the conditional statement, and that is a true statement. If two angles are supplementary, then their sum is 180 degrees. Okay, so we know that's true. Now we need to look at the converse. If the sum of the measure of two angles is 180 degrees, then they are supplementary. That's also true. So since both the conditional and the converse are true, that leaves the truth value for the biconditional to be true. So here in example 2, I wear my snow boots if and only if it snows. We're first going to write the conditional statement going from left to right, so this red arrow, and then we'll do the converse going right to left, following the blue arrow to write the converse of it. So here are those two statements based on this biconditional. So if I wear my snow boots, then it snows. That's the red arrow going from left to right. The converse, if it snows, then I wear my snow boots. That's going from right to left. So now we just have to decide if it's true or not. Okay, conditional statement says if I wear my snow boots, then it snows. That is going to be false, because you could wear your snow boots just because it's cold outside. if it snows, then I wear my snow boots. Now, I would say that that's true because you want to wear your snow boots when it snows. But because both are not true, the truth value to this biconditional cannot be true. So we would call it false, but we would have to specify, and we're going to say that the conditional statement is false, just so that it's clear which one has failed. So in number 3, we're going to do the same thing. So you complete it and then resume the video for the answer. Okay, so for number 3, we have the conditional being if x squared equals 25, then x equals 5. So the red direction. The converse, going in the blue direction, if x equals 5, then x squared equals 25. So we'll notice that the conditional is false because x could actually equal negative 5. However, the converse is true. But nonetheless, we have to have both of them true in order for the biconditional to be true. So in this case, the truth value is also false due to the conditional being false. Let's go ahead and try number 4 and resume the video when you're done. Okay, number 4, the conditional, if I got 10% off, then I spent at least $75. That's a true statement. If I spent at least $75, then I got 10% off. True statement. So the truth value here ends up being true because both the conditional and the converse are true.